In this section, we will discuss the implementation of convolutional neural network. So following is the given table of content. First, we will discuss what is convolutional neural network. Next, we will discuss the components of convolutional neural network. In the end, we will discuss the implementation of CNN. First, we will discuss what is convolutional neural network. So basically, convolutional neural network, also known as CNN, and it is used for computer vision applications, and it is a class of deep neural network that are used to analyze visual image. So this type of architecture is dominant to recognize objects from a picture or video. So it is used in applications like image or video recognition, neural language processing. So basically the main difference between the CNN and other neural network is that CNN takes input as a two-dimensional array, while in the other neural network it takes as an n-dimensional array. So the most key component in the model in CNN layer is that it is used to reduce the size of the image for the faster part of the weights and to better its generalization. Now during the case of CNN layer, the network keeps the necessary features of the image and excludes irrelevant noise. So if you use a traditional neural network, the model will assign a weight to all the pixels, which is not necessary for the network. So instead of a Keras convolutional neural network, we will use a mathematical technique to fetch only the most relevant pixels. So this mathematical operations is called as convolutional. So this technique allows the network to learn increasingly complex features at each layer. So the convolutional divides the matrix into small pieces to learn the most essential elements within each pieces. So this is the image of convolutional. Basically it is an element wise multiplication. So basically the computer will scan a part of the image, usually with the dimension of 3 by 3, and it multiplies it to a filter. So the output of the element wise multiplication is called a feature map. So this step is repeated until all the image is scanned, and after that the convolution size of this image is reduced. Now we will discuss the components of CNN. So there are 4 types of components. First we will discuss convolutional, after that we will discuss ReLU, and next we will discuss the pooling, and last we will discuss the classification, which is also known as the fully connected layer. Now first we will understand what is convolution. So the main purpose of the convolution is to fetch the feature of the object on the image. In simple words, we can say that convolutional means element wise multiplication, and the computer will scan the image usually with the dimension of 3 by 3 matrix, and the dimension of the image matrix is represented as h into w into d, and the image of the output is fh into fd into d. So in this case h will be the height, w will be the width, and d will be represented as the dimension. Now we will discuss the next component of CNN, that is ReLU. So basically this function only activates the nodes if the input value is above a certain quantity. So it will check the condition. If the value rises above a certain threshold, then it has a linear relationship between dependent variables. So here we will remove every single negative value from the image. Now we will discuss our next component, that is pooling. So basically the pooling layer is the most significant role in the pre-processing of any image, and it will reduce the number of parameters when the size of the image is too big. So pooling is also known as the downscaling of the image processed by the previous layer, and it also equates with the shrink image to reduce the image density. There are basically 2 types of pooling in the CNN. So first we will choose the window size and then select the stride usually across filter image, and each window take the minimum element. There are 2 types of pooling in CNN. First we will discuss max pooling. So basically the main purpose of max pooling is to reduce its dimension, except the assumption to be made about the feature stored in the subregion. So max pooling used to apply the max filter and overlap the subpart of the first representation. While in the case of average pooling, it will divide the input value into the rectangular pooling range value. Next pooling is average pooling. So it involves calculating the average pooling by dividing the input into rectangular pooling. In simple words, we can say that it will return the average of all the values from the specific part of the image. Now we will understand the implementation of CNN. So here is the example. In this example, first we have imported the necessary libraries, that is TensorFlow and the Keras libraries for dataset, and also for plotting the graph we use the matplotlib library. Now after that we download and prepare the CIFAR10 dataset. So basically the CIFAR10 dataset contains 60,000 color images in 10 classes with 6,000 images in each class. So the dataset is divided into 50,000 training images and 10,000 testing images. The classes are mutually exclusive and there is no overlap between them. Now we will verify the dataset. So let's plot the first 25 images from the training set and display the class name. So we have mentioned the class name within the list. So after executing this code, the output comes the images of the training part. Now these lines of code defines the convolution base using a common pattern. So it takes a conv 2D and max pooling 2D layers. So as input, a CNN takes tensor of shape, image height, image width and color channels. So if you are new to these dimension, color channels refers to RGB. In this example, you will configure your CNN to process inputs of shape 32 with 3,3, which is the format of CIFAR images. You can do this by passing the argument input shape in it as a 32, 32, 3 to your first layer. So to complete the model, you will feed the last output tensor from the convolutional base of shape 4464 into one or more dense layers to perform classification. So dense layer takes vector as input which are 1D, while the current output is a 3-dimensional tensor. First you will flatten the 3D output to 1D, then add one or more dense layers on the input. So after that we will compile and train the model. So after compiling the model, it displays the 10 epoch. So after that we evaluate the model, displays the plot of accuracy and val accuracy. So CNN has achieved a test accuracy of over 70%. So with this we have completed the implementation of CNN by using TensorFlow.